what do you do at 36 weeks? Do you do an amnio? If the baby has Downs, what are you going to do about it at that stage? So this identified, if you like, the problems that we have when inherently a screening program goes wrong, where we've not recognized it, and where we have to clear that mess up at a later stage. So that was a biochemistry-based problem. If we look at Down syndrome screening more broadly, many of us use this process of combined first trimester screening, doing an ultrasound scan at 11 to 13 weeks and 6 days gestation, where we measure markers such as nuchal translucency thickness, the nasal bone. You may look at the ductus venosus, you may look for tricuspid regurgitation. But we have a process for screening. In our population, we have identified that all women should be offered a screening test, so that is an auditable standard. We also recognise that all women have to have access to a scan at 11 to 13 weeks and 6 days, so that's another recognised standard. And then we have all of the data from the screening process that we can identify and test. So if we just take nuchal translucency as an example, the image on the right-hand side shows a first trimester fetus. It actually has an increased nuchal translucency. You can see some attempt at imaging the nasal bone as well. There are some things that are quite nice about this image. It's a nice, large image of a mid-sagittal section of the fetus. The fetus is in a relatively neutral position. The nuchal translucency is well imaged. There's no actual caliper placement on this image, so I can't comment about that. On the left-hand side, you can see what your Down population would look like in relation to a normal range. So you can see that the red dots show that about 70% of Down fetuses will have increased nuchal translucency compared to the normal range. How do we actually use nuchal translucency to adjust risk? Well, we don't, in reality, just use a fixed measure where we say this is normal and you're high risk, or this is abnormal, sorry, this is normal and you're low risk, or this is abnormal and you're high risk. What we do is we combine it with the other factors, such as maternal age, because we know that as women get older, their risk for Downs goes up, and we combine it with biochemical factors, the hormones PAP-A and beta-HCG. So in order to combine all of these different features, we actually need to give our nuchal translucency measurement a numeric level of risk that we call a likelihood ratio. How likely it is that this marker shows the baby has Down syndrome compared to it shows this baby is normal. So on this graph here, you can see if I take all of the nuchal measurements in a normal population, they are essentially normally distributed, and I can convert the absolute nuchal translucency measurement, because I know it's reliant on gestation, it changes with gestation, so I can account for gestation and convert it into a measurement called a multiple of the median. So if I know your crown rump length, sorry, this is the normal distribution for normal population. And if you have one multiple of the median as a measure, that tells me you're in the middle of this population. You can see if your beta-HCG, for example, is increased and you are 2 multiples of the median, you can see you could be in either the normal population or in the Down population. And for beta-HCG, if you just look at the distribution of measures in a Down population, they are right-shifted in comparison to the normal chromosomes. So let's say I measure nuchal translucency. It's like the image I showed you before. It's very big, and when we work out what that measure is in the context of a normal distribution, we find it's 3 times the multiple of the median. That actually means that it's now much more likely that you're in the Downs population than you're in the normal population. And we can apply that likelihood ratio to the background level of risk to take account of what we've just measured and assessed on ultrasound. Now, why am I going on about this? The reason I'm going on about this is that if I make an error in my nuchal translucency measurement, then I'm going to make an error in calculating the multiple median of the nuchal translucency measurement, and then I'm going to make an error in defining the likelihood ratio for how likely it is that you're in the Downs population or the normal population. So the first thing is, our clinicians have to have an understanding and appreciation of the fact that the nuchal translucency measurement is important as part of this test. And it's important that we make that measurement in a standardized way in measurement. So in order to make the measurement in a standardized way, we have a standard operating procedure. We do the test at 11 weeks to 13 weeks, 6 days, when the fetus has a crown rump length of 45 to 84 millimeters, using a mid-sagittal section of a relatively large image, so it's easy to measure things. The fetus needs to be in a neutral position away from the amnion, and we measure the maximum nuchal translucency with the calipers in a very specific position. And if I'm assessing one of my colleagues and their performance for nuchal translucency, I can actually go through their images and look at all of these criteria and then score these criteria. So these are some images that have at times been submitted for assessment. The image on the left isn't large enough. We haven't maximized the space of the size of the head and the thorax so that we get clear measurements. The image second along, this one here, shows a fetus that is an appropriate size, but here there's no obvious caliper placement. This image here is not mid-sagittal, and this image here is not mid-sagittal. So we immediately have a means of scoring whether these images are appropriate or not appropriate. The problem with individual image assessments in quality assurance is that it takes a long time, and you need a second expert to be able to review those images, so it's expensive. Another way of assessing the nuchal translucency measurements is to look at all of the work that someone did over a period of time, and then to publish the nuchal translucency measures that that person made compared to the normal range. And if you just look at this distribution of measures, you can see that it looks a little bit low on those centiles. It looks as if generally this individual is under measuring nuchal translucency. So we use this in Australia for a national audit we do of everybody providing nuchal translucency measurements for screening for Down syndrome. And at the moment we have about 770 operators nationally who take part, providing measurements for about 150 to 170,000 first trimester scans that are done each year. Now, we've been doing this audit over several years, and one of the things that you can see is that when we started this process in 2002, we were actually under measuring. You can see that these dots are the individual operators, and you can see there's a large body of them measured more than 50% of their images were below the 40th percentile, which was our defining point for you're outside the normal range. And by 2008, with some ongoing education, we've managed to have the vast bulk of our operators between the 40th and 60th percentiles, but we still do have quite large tails. When you're running this program, which is currently my job at the college committee for this, when I'm given this data, I actually know the IDs of these people who are at the extremes. And so we have the ability to talk to those individuals, ask them why they think their distribution's outside of what would be defined as normal criteria, and then try to apply some approach of retraining to bring them back into the fold. The Fetal Medicine Foundation in the UK does this in a slightly different fashion. It looks at nuchal translucency distributions, looking at the spread of the distribution, so you can see what proportion are above the 50th centile, what proportion are below the 50th centile. And here, in the way that they report this was reported with a green traffic light, saying that this is okay. But they also look at the distribution of the measurements. So you can see here the standard deviation is too large. That will affect the likelihood ratio that you generate. And they also actually look at the skew of the distribution. So what proportion of measures are above and below the 50th centile at 11 weeks compared to at 13 weeks and 6 days. Now, when you're using a test that has multiple components, so combined first trimester screening uses baseline maternal demographic data, it adds the nuchal translucency measurement, it adds the biochemistry, beta HCG and PAP-A. When you're using a combination of those tools, you actually, to some extent, remove the risk of one of the tools being measured badly. So that's one of the reasons we like to use the combined tool. So for example, here on the left, if your nuchal translucency measures you're making as an individual or as a group are not deviated from normal, you can see that when you use nuchal translucency alone with maternal age, you have about a 70 to 75% detection rate. If you add in the biochemistry, it's more like an 85% detection rate. If you were to be under measuring your nuchal translucency, then your detection rate would actually drop quite significantly. So you can see it coming down to about 50% if you're under measuring by about a millimeter. But if you're doing biochemistry as well, and the biochemistry is being done appropriately, then it negates some of that risk. It works the other way as well. So for example, on the right-hand side, if you're over-measuring nuchal translucency, then you'll have more women being defined as being at high risk. So you can see here, if you're using nuchal translucency as the sole tool, that when you're over-measuring by 1 millimeter, instead of having a 5% false positive rate, you're going to have something more like a 40% false positive rate. And again, if you add in the biochemistry, it negates some of this risk. And this is just an example of what the effect of bias is, both in your false positive rates and in your detection rates. So let's look at another ultrasound marker, one that we don't measure, but we just look at it qualitatively. So this is looking at the nasal bone. The nasal bone is this structure here. This is a normal nasal bone.